Is that useful?
Mm-hmm.
Is it worth me printing off the paper now so we can talk about the paper? Or
Okay.
yeah, just to make sure. Is it working or not?
Yep.
Okay, so the first thing to do is to create one of these graphs.
Yeah. I have a question that.
So do 1 over t1.
So you need to check it that the data we got. This is T1 actually.
This is t1, yeah.
And it tells B the size of. How could we go to the B here?
Well, you don't. You're going to be using this equation here.
Yeah, we don't need this.
Yeah, all the b's have cancelled. It turns out when you do the maths.
And how I got I've seen this part that, but I don't know how could it works.
Okay. Well, you're going to first of all you choose a frequency.
Yeah.
Okay. And then you take 1 over t1. Make sure you do it in units of per second.
Yeah.
Okay. Plot it against log molecular weight. So that's log of 300, log of 400. Yes. They're the molecular weights. Got it. We use that in grams per mole. So it's log of 300, log of 400, log of 600. Happy. So for one frequency, you generate one set of data like that.
Yeah.
You fit a straight line, and you'll get from that the gradient and the intercept. Yeah, the gradient, yeah, the slope, and the intercept.
Yeah.
Yes. The gradient is, if you look at this, this is true. Gradient is 6 delta squared tau over pi.
Yeah.
That's that bit. The intercept is minus 6 delta squared 12 over pi, yes,
Yeah.
log NAM.
Yeah.
So that's your gradient,
Yeah.
that's your intercept.
Mm-hmm.
So if you look at this, the intercept over the gradient is minus log NAM.
Oh, yeah.
Yeah? This M is 44, therefore NA, we now know it from this. Got it?
Got it.
Yes? Once you know NA,
Mm-hmm.
yes, you take the NA
Yeah.
and you stick it into here,
Yeah.
and you have the delta.
Yeah.
These are all numbers. Yeah, the D is here somewhere.
Yeah. Uh-huh.
Yeah?
I don't know.
You have the
Already know.
delta.
Yep.
Once you know the delta,
Mm-hmm.
use the gradient
Yeah.
to get the torr. So this will give you the NA, and it will give you the torr. Make sense?
Yeah.
There you go.
And this is the first step, and
So then
we could go to NA.
you can play NA versus temperature,
Yeah.
NA versus frequency, torr versus temperature, torr versus frequency, and when you choose any one frequency, doesn't matter which one, does your torr follow that temperature dependence?
Yeah. But how could this become come to this?
We'll try it. Torr is this. Torr dot is differentiate this with respect to temperature.
Yes.
You do the maths, and you'll find that the ratio is this. Try it. Just you differentiate it in your own time. Differentiate this with respect to t. Okay, that's what that is.
Yeah,
Torr
I know
dot,
it.
and then put that in, and you'll see that it becomes this.
Mm-hmm.
You don't need to do this bit. You need to do this. Okay, and then if you want to do this, you have to read over here and understand it.
Yep.
Okay.
Okay.
Does that help?
Yes, and do I need to know that I don't know? It gives error here. How can I use them?
Well,
And the zone and frequency.
so that's the error in what? In T1?
I think it's error
Is your-
41.
Yeah, it is.
It's
Yeah,
error
there's your
for
error in
our-
T1. Yeah.
And how do I need to use this data? How could
Well,
I
you can do
use it?
because look, your T1s will have errors.
Ah, it looks like this.
Yeah, which
Alright.
is what this is.
Oh yeah,
Okay. So it's plus or minus this.
it's for R1.
Yeah. So
Yeah.
R1. So yeah,
Yeah.
this is R1.
Oh right.
Yeah. So it's the right thing.
Yes, yes.
Okay.
That's it. And so does the frequency here matters?
Well, yeah, because you can do this for as many
Oh.
frequencies as you like. This is so you can do this for as many frequencies as you like. So all these points are at one frequency.
From one
Yeah,
frequency.
you choose.
Yeah.
Why not have a play? Try some low frequency, try some middle frequency, try some high frequency, have a see, what's the effect, and so on.
Good.
That makes sense?
Yeah. And the data here. So the tau here and when we do the experiment, we set the tau and the relaxation time, delay time. How does it matters? How does it work?
I don't know what that tau is in that pulse sequence, because the different machines have different pulse sequences and have different symbols.
Yeah.
So I don't know what tau that's referring to in the pulse sequence. But I mean, for what you're doing now, that's not important because you don't, you know, why.
Just decided to make it Oh.
It's okay because you're treating it as a machine that measures T1 as a function of frequency. You've only got 3 or 4 weeks. I mean, it's too much to try and understand all that. I mean, the only pulse sequence that you might try to understand is something called the spin lattice relaxation time.
Yeah.
Okay, because this is effectively doing the spin lattice relaxation. So you have a look at that pulse sequence, try and understand that. That's enough, I think, for this 3 or 4 weeks. Okay.
Okay.
But the most important thing now is the analysis, is to try and do this.
Okay, I know.
And see how it goes. Is it okay?
That's it.
Yeah, so if I give this to you, and then you have a memory, and then you guys can try and do this and see if it works. Okay?
Thanks a lot.
That's great. Well, good luck.
Yeah.
You can always, if you get stuck, you can email me, yes?
Yeah.
Okay. Feel free. No, it's my pleasure. Thank you. Good.
Thank you.